All right, we're getting closer to the end of the year, and here we are starting rational expressions. In this, you're going to learn to simplify rational expressions, and you're going to learn how to multiply and divide rational expressions. Because your favorite thing to work with is rational expressions. So you kind of get the idea of what I'm going for here. Anyways, so what is a rational expression? A rational expression is a ratio of two polynomial expressions. What does that mean? It's a fraction. It's a fraction. So there you go. It's a fraction. Dealing with, say, polynomials. So two of your favorite subjects of all time in Algebra 2. What can I say? All right, so what do we do to simplify? Let's start off with something easy. You want to simplify, let's say, 8/12, and you should already know how to simplify that to 2/3, besides, say, typing it into a calculator. Well, back a long time ago, you may have been told find the greatest common factor and divide both that can divide into both numbers and divide them both. Let's try something different. How about we rewrite it as 2 times 4 and 3 times 4? And then you could see, oh, look, 8 is 2 times 4, 12 is 3 times 4. They both have a common factor of 4 that can cancel out, leaving me with 2/3. So 8/12 simplified is 2/3. You can do the same thing with polynomials. The idea here is that you got to first learn how to factor. You got to make sure you know how to factor. So you look at x squared minus 4x plus 3 and x squared minus 6x plus 5, and you can go, oh, hey, minus plus can be minus minus. X, and what two numbers multiply to give you 3 but would add up to 4, well, 3 and 1. What do two numbers multiply to give you 5, add up to 6, 5 and 1. And then the x minus 1s would cancel each other out, leaving you with an x minus 3 over an x minus 5. Simple. All right, so the easier you know how to say, the better you know how to factor, the easier this will be. That's going to be it, plain and simple. All right, so let's look at another one. So we got 5x times x squared plus 4x plus 3, x minus 6 over x squared minus 9. Well, the x squared plus 4x plus 3, that should simplify to an x plus x plus. Okay, so what two numbers multiply to give you a 3 and add up to 4? Well, 3 and 1. Because those are the only two numbers that multiply to give you 3 anyway. So 3 and 1. The x minus 6, you can't do anything. It's linear. The x squared minus 9, there's a special one that we did with that. That would say x plus, x minus, and what two numbers? Just take the square root of 9 and you got 3. So those are two numbers that multiply to give you x, that would factor. Now, before we actually start canceling anything out, you also need to define the undefined. Yeah, that comment made sense. You need to find out where are the undefined points. You focus on the denominator, which is the bottom, and basically look at each parentheses individually. Any of them that would give you zeros, that would be where you would be undefined. Because you can't have 0 in the denominator, and 0 times any of those would give you undefined. So, just think opposite. What's the opposite of a negative 6? Positive 6. What's the opposite of a positive 3? Negative 3. What's the opposite of negative 3? Positive 3. It's kind of as simple as that. Yes, there's ways I can make that harder, but that makes it kind of simple. Now, I know where I'm undefined. Now I can cross out the common factors. Boom, boom. And I can say that this simplified is 5x times x plus 1 over x minus 6, x minus 3. I need another example of this, sir. You don't say. Let's look at another example. Okay, so you can see the top part is already factored, so now I need to factor the bottom part. Minus minus is a minus plus, and I'm looking for two numbers that multiply to give me 6 and would subtract to give me a 1. Negative 1, actually. Two numbers that multiply to give you 6 are 3 and 2, so it should be negative. Remember, bigger number always went on the left. Negative 3, positive 2. This might be where you want to make that chart where that helps you to kind of realize like plus plus was minus plus, or plus plus was plus plus, minus plus was minus minus, things like that. That might help. Okay, so we can see here. Now, again, where are we undefined? Well, we're undefined at if you focus on the last one, that's negative 2. The next one in the middle is positive 3. What about y by itself? Well, 0. Because if you put a 0 in place of that y, you're saying 0 times anything. I don't care what the rest of it is. It would give you an undefined point because 0 times anything is 0. So anytime you see a variable by itself, don't forget to put a 0. Even if I had like 4y in front there, that still would have been 0. If I don't see a plus or minus, think that you're probably going to have a 0. Anyways, okay, what crosses out? The y minus 3. So there you go. And there it is simplified. And you got your answer. Bada bing, bada boom. There you go. It's easy, right? Okay, next part. Let's multiply or divide. Okay, so for multiplying and dividing, what I like to do is make sure I simplify. To simplify, I like to expand and cross out the common factors. So what do I mean by that? I'm going to use some numbers. And this is probably not what I would normally do if I was doing numbers, but since I'm trying to do this also for variables, you can kind of see. So 6 is 2 times 3. So I write 2 times 3. 15 is 5 times 3. So I'm going to write 5 times 3. So notice how I'm breaking these down to their prime factors. 5 is, of course, 5 times 1. And 8 is 2 times 4, but that means I can break up the 4 to be 2 times 2. So I'm going to write 2 times 2 times 2. So notice how I expanded these to represent all the numbers. So I can say a 5 and a 5 could cross out, a 2 and a 2 could cross out, and that's it. You can only cross out top and bottom. So there's a 2 3's left over. 3 times 3 is 9. And there's a 1 times 2 times 2, which is 4. And there's your answer. Okay, so you're going to do the same thing with variables. So here's our first one. Okay, so I'm going to break out the 12, and I'm going to make that 2 times 2 times 4. 2 times 2 times 3. Whoops. And the 14 would be 2 times 7. I'm not going to even worry about the letters just yet. I'll put those at the end. And then I put the letters. D. D squared is 2Ds. And then there's a B. So I'm even going to write out all the variables based on the exponent that tells me how many I have to write out. That way you'll get your most accurate answer. Okay, so 21 is 3 times 7. And 8 we've already established is 2 times 2 times 2. And then I've got a B and a 2 C's. Okay, so I can cross out 1, 2, and another 2. I can cross out another 2 and another 2. I can cross out a third 2, and there we go. I can cross out the 3's. I guess I can cross out the 7's too. Wow, everything crossed out. So that means then all I have is a 1. But I don't even need to put that. Okay, so and then the B's cross out. So that leaves me with D squared, because 2D's is D squared. And C, 2 C's would be C squared. So my final answer for all of that is D squared over C squared. All right, next example. Give me another example, sir. I'm trying to get the hang of this. All right, 6 is 2 times 3. 21 is 3 times 7. And then I have a Y and an A. And I don't care the order of the letters or the variables, just put them there. 15 is 5 times 3, or 3 times 5. And 8 is 2 times 2 times 2. I'm really stuck on 8 lately. Or at least the book was. I was copying examples from the book. Okay, and then I got another Y and an A. All right, so let's see here. A 3 and a 3 cancel. A 2 and a 2 cancel. That's it. Y can cancel. A can cancel. Okay, well, I guess I'm not canceling those out yet. All right, so number-wise, I have a 3 and a 7 left on top. That's 3 times 7, which is 21. Wow, that's interestingly coincidental. And then 5 times 2 is 10, and then another 2 would make 10 times 2, 20. So there's 20. The Y's cancel, the A's cancel, and that's it. I'm left with 21 over 20 as my simplified answer. All right, so again, you kind of see, the more you practice with these, the easier these will actually get. I like to draw these out because I think that makes it a little bit easier. Oh no, now you're going to throw us dividing. Well, what do we do when we divide? Remember, when you divide by fractions, you multiply by the reciprocal. So let's show multiplying by the reciprocal. Oh my gosh, everything flipped over on the second one. Duh. You got it. Don't worry. All right, so what is 18? 18 is 2 times 9. So and 9 is 3 times 3. So 2 times 3 times 3. 35 is 5 times 7. You got to know your prime numbers. It's really helpful to know your prime numbers here. 7 is just 7. Oh, and I'm going to put the X and 3 Y's and 2 A's and a B. I was trying to squeeze everything in. All right. 7. And then 12 is 2 times 6. And 6 is 2 times 3. Then I can put 2 A's, 2 B's, 2 X's, and a Y. All right, so what can I cross out? I can cross out a 7. I can cross out a 2. I can cross out a 3. That would leave me with 15 over 2, it would appear, because I got 3 and a 5 on top. And I got only a 2 left on the bottom. Now let's start crossing out variables. X and X. Y and Y. A and A. A and A. And a B. So what am I left with on top? I'm left with just a y, 2 y's, which is y squared. And then I'm left with a b and an x, so I can put bx or xb. Whoops. I missed the b. There you go, xb. All right. I actually missed that. Oopsie. All right, so last example, and then I can let y'all try to work on these on your own, because you'll be ready. All right, so we got here 12x to the 4th. Remember, flip it because we want to multiply by the reciprocal. Hi, Tigress. Okay, bye, Tigress. All right, excuse the cat. All right, so 12 is 2 times 2 times 3. 16 is 2 times 2 times 2 times 2. A lot of 2's. And then I could have 4 x's and 4 y's. I'm sorry, 2 y's, and then 2 a's and a b. Notice how I'm trying to put everything together on top. Then on the bottom, 40 is 4 times 10, and 4 is 2 times 2. 10 is 2 times 5, and then 6 is 2 times 3. Then I have to have 4 a's, and 4 b's, and 2 x's, and 4 y's. I was running out of a lot of letters. Takes up a lot of space, but this really does make things a little bit easier. 2's cross out. A 3 can cross out. Another 2 can cross out. Another 2 can cross out. And I'm left with 2 times 2 is 4. And then I got a 5 on the bottom. Now let's cross out variables. X's cross out, 2 x's, so I'm left with an x squared on top. 2 y's are crossing out 2 sets of y's, so I'm left with a y squared on the bottom. 2 sets of a's are crossing out, and 1 set of b's. So if you look here, based on that, I've got an x squared on top. I've got an a squared, b cubed, oopsie, b cubed, and a y squared. And that is it. And there you go. Kind of a lengthy one, but we're covering a lot of ground here, and I'm sure we'll have to do a little bit more, but y'all can do a great job on this, all right? I will look forward to y'all showing these notes to me, and I will see y'all later. Y'all take care. Thank you.